Hi, we're going to be looking today at 7.6, which has to do with similarity in the coordinate plane. So I'm going to write down similarity and coordinates. Now, part of the good news is we've already dealt with the idea of taking a shape, for which I know the coordinates, and then doing a dilation about the origin, which is to simply expand the figure. What we're going to look at now is the idea of calculating back to get the scale factor and to find any other points we may need along the way. So let's get ourselves an axis to play with. In fact, let's actually go a step further. Let's get out some graph paper. We're going to be working exclusively in terms of the coordinate plane, so we can just put this all on some graph paper. Be a little easier to see what we're doing. So I'll mark off an axis on my paper. I'm going to work in quadrant 1, mostly just to keep the math easy for us today. And I'll go ahead and I'll draw a triangle here. So we'll use the origin, we'll call that A, 0, 0. And let's use this point here. Actually, no, let's not get that far down the line. We'll use this point here. And that's going to be B. And that's, as we can see, 1, 2, 3, 4, comma 0. And then we'll use this point right here. And that's going to be, let's see here, 1, 2 by 1, 2, 3, 4, 5. So that's 2, 5. And that's point C. Now, let's go ahead and draw some lines in there. And so for this example, there's my original triangle. I want to talk about doing a larger version. I'm going to do a dilation on it. My dilation is going to continue up to the point, let's keep it simple on the math, 410. So that's going to put us up right around there. So that's my C prime. So I know C prime is right here. And that's at 4, comma 10. Now, I also know where the other line is going to come down to. So I know this is over here. Looks like that. Now I've got graph paper in front of me, which means I can count off if I want to find out what B prime is. My goal, however, is to come up with B prime without relying on the graph paper itself to see it. Now that is an option kind of to help check our work, but I want to get that coordinate some other way. Also want to come up with a scale factor. So let's take a look at what happened. We know from what we've talked about before in class that if I take a coordinate and multiply it by the scale factor, the new coordinate gives me the image. So what I've done somewhere along the line here is I've taken the coordinate of C and I've multiplied it by some scale factor in order to come up with C prime. 4 came from 2 times something. 10 came from 5 times something. So we have to ask ourselves, 2 times what gave me 4? And 5 times what gave me 10? And they should be the same number. Simple mental math tells me then that my scale factor had to be 2. So now I've answered one of my 2 questions. I now know the scale factor of this dilation. Now the second question, what's B got to be? Well, if I take 4 and I multiply it by 2, I get 8. 0 multiplied by 2 puts me at 0. So B prime must be 8, comma 0. And there you go. We're still working with the idea of tying together dilation and coordinate dilation, where we simply multiply all the coordinates by a number, and that then gives us that expansion from the origin. Now, there are other tools I can use to get to these values, to get to these ideas. So let's take another piece of graph paper. And on this one, I'll go ahead and I'll put my axis on here. I'm going to go ahead, I'm going to draw a triangle there. And let's see, make sure I put it where I want it. 6, and 2, 4, 6. All right. Actually, this is what, 2, that's 8. Let's go ahead and let's go up to 9. There we go. So there's a triangle. And I want to do one that is similar, but not quite as big. So there it is there. Now I know some coordinates. Let's say, again, I've got my A, my B, and my C. And we'll say that this point is D and this point is E. And let's also add in that we know that triangle ABC is similar to triangle ADE. So I know that coming in as a fact. Now, from what we said about similarity, that means we know the sides are proportional and that the angles are all going to be congruent. So let's get some coordinates on here. Let's continue with my givens. B, and I'll go by what's marked off here, is going to be at -6, 0. And let's say that up here, this is going to be at, 2, 4, 6, 8, 2, 4, 6, 8, 9. 0, 9. And let's go ahead and we'll say we know what E is. We know E is going to be at 0, 3. So I want to come up with the coordinates of D, and again, not relying on my graph paper. I want to come up with one mathematically. Now, since these guys are similar, I know there's going to be some scale factor at work that I can use to figure out what this point has to be in order to maintain that constant ratio. Now, there are some other things I can use. The best strategy really, I think, is to come up with a scale factor and apply that concept. Or you could also look at it as coming up with a proportion of some kind. Think of that distance as x. Let's go the proportion route first, and then we'll talk scale factor. If that distance is x, let's get some other distances. Up to 0, 9 is going to be 9 units. Over to 6 is going to be 6 units. And up to 3 is going to be 3 units. So I can write a proportion that will help me do this. 9 is to x as, no it's not, 6 is to x as 9 is to 3. That would be the proportion I could use to come up with how far x is. I can then use that idea to identify the coordinate of x. So now, or of D. So let's go ahead, we'll finish up the math. Cross multiply, I get 9x is equal to 18. Divide both sides by 9, x must be 2 units. Since x is only 2 units, the coordinates of D have to be 2, 0. That way x is only 2 units long. I could also approach this using a scale factor. For example, what's the scale factor of 9 and 3? Well, if I put 9 over 3, I get a factor of 3. So that means I want to take 6 and scale it by a factor of 3 down. So if I'm asking myself basically, 6 divided by what is going to give me that scale factor of 3. And then when I solve that, I'll get my x is equal to 2 again. I can then use that idea to come up with that 2 units. Now, it's not an exact dilation, because if I were to simply multiply -6 by a third, I'd have -2. And that would give me this triangle here, which isn't the one I'm looking for. So it's a little bit more work to use the properties we've talked about in order to get that coordinate of 2, 0. Let's look at one last example, but this time we're going to take away the graph paper, so we don't have that as a crutch to help us verify our answers by counting. So here I'm going to be working, and again, I'm going to stay in quadrant 1 to keep things simple, but I just don't really need to. Here I've got 2 similar figures. So there's that and there's that. And let's say that this has the coordinates. This is the coordinate of 10, 0. And this is going to be 15 comma 0. And this here is going to be 5 comma 0 comma 5. And this is what I'm trying to find up here. Now, one strategy is to try to figure out what the scale factor is, and then multiply that 5 by it in order to get my new value. Another option I have at my disposal is to make a proportion. So if you think about it, this distance here is 10 units. This distance is 15. This distance is 5. And this distance is the one I'm trying to come up with. So I can write a proportion that uses that. My proportion then is going to be 10 is to 15 as 5 is to x. So I'm going from this length, 10, to a related length, 15. I'm going from small triangle to big triangle. And now I can go ahead and I can do whatever this asks me to do. I'm a little rusty on my 5's tables. 15 times 5, 5 carry the 75, there you go. So that's going to give me cross multiply. I get 10x is equal to 75. Divide both sides by 10. I get x is equal to 7.5. Now, be careful. I used x as my unknown. However, it's in the y direction. So my final answer, this ordered pair, is going to be 0, 7.5 to represent the fact that we're talking about something that's in the y direction. One of the big things that happens is we tend to mix x and y when we look at these problems up because we like to use x as a variable even when we're looking for a y value. Again, the idea here is to go back to what we've been talking about with similarity and being able to write a proportion that lets us make a prediction. All right, we'll see you guys in class.